All right, we're taking a look at 6-3, which is solving rational equations. Pause the video for a second and take a look at our EQ. Why is finding a common denominator important in solving rational equations? Okay, so we're not even going to address the EQ right now. We're going to first take a look at some of the stuff you've already learned how to do, like stuff from Algebra 1 and even pre-algebra, just to reinforce what it is we're trying to do. Okay, so here's the first one. We've got a fraction on each side of the equation, on each side of the equal sign. Now these ones end up being really easy. We want our variable in the numerator, so now and only now, this is the only time ever I'm going to suggest that you actually cross multiply. As you guys know, I don't like cross multiplying, so we're just going to run through this real quick. This is the only time you can do it. Cross multiplying 5 times 9 gives me the 45. 3 times x gives me the 3x. Now, it's just as simple as solving for x. We divide both sides by 3, and we get 15 equals x. Super easy problems, right? Stuff we've all done before. Let's take a look at a couple more and kind of increase the difficulty as we go. Okay, number 2, we have n divided by 2 equals 6 over 11. So this, again, is the only time that you can use cross multiplication whenever you see just one fraction on each side of the equal sign. Go ahead and cross multiply. We get 12 equals 11n. We divide both sides to isolate our variable. And we have 12 over 11. Don't worry about if you get weird fractions. A lot of times these problems, which are also known as proportion problems, we get fractions. They won't reduce necessarily. So don't freak out about that. You didn't necessarily do anything wrong. Just go through the process. Okay? Next one, we cross multiply again. Think about this a plus 8, though, in parentheses. That's going to be really important for us. So we have 4 times a plus 8 equals 7 times 3, which is 21. Okay? Now you can do one of two things. You can go ahead and distribute that through. But here's what I kind of, in this case, I could think about dividing both sides by 4. But does 4 go into 21 evenly? No. And we don't want to mess with remainders. We don't want to mess with these improper fractions or anything like that. So I'm going to actually distribute this, make it a little bit easier for myself. Distribute the 4 through. We have 4a, and then 4 times 8 will give us 32. Equals 21. Work on getting the a by itself. Remember, we want to do our order of operations in reverse when we are trying to solve equations. So instead of taking care of the multiplication division with that 4a, we subtract 32. We have 4a equals 21 minus 32 is negative 11. Now we can divide by 4. And we have a equals negative 11 over 4. Okay? So even when we have a binomial, something with two terms in our numerator, that's not a big deal. Okay? We deal with it the exact same way. You just have one more step of distributing. That's it. Okay? Next one, 2 fractions. And you might think, well, wait, can I cancel out these p's? Remember, these, think about them in parentheses. And they must be identical inside the parentheses before we can cancel anything out. So nothing's going to cancel. But we do have one fraction on each side, so we'll go ahead and cross multiply. We have 7 times p plus 7 equals 9 times p minus 9. Go ahead and distribute once again. 7 times p, 7p. 7 times 7 gives us the 49. Distribute the 9 through on the other side of the equal sign. We have 9p minus 81. Okay? Let's go ahead and work on getting the variables all by themselves. So I like to work with larger numbers. I want to work with positive numbers, so I'm going to move my 7p to the other side, so that way I don't have a negative value that I'm working with. Excuse me. Let's try and get back to the right page. Subtract 7p from both sides. 7p's cancel out here. We're left with 2p on the right side. And in the same step, we really can move the 81. That's no problem as well. Move the 81 to the left side. And here, 49 plus 81 gives us 130. Divide both sides by 2. And we get these that cancel out. And we're going to have p equals 65. And there's our solution. So these ones are all problems that are going to be based on One fraction on each side of the equal sign. When we take a look at the next few examples, this is where it gets more complicated. Okay? Looks really nasty, looks really gross, but we're actually going to find a really nice shortcut. And much like with our radical equations, we wanted to turn Algebra 2 problems into Algebra 1 problems. That's exactly what we're going to do. So, stop, go back over the other examples, rewind if you need to. Return by looking at the next video, solving rational equations with fractions on both sides of the equal sign.